Welcome, everybody. This is the Quarto workshop series. This is our 6th workshop for this semester. Another person. Today, we'll be taking a look at structural equation modeling in R with the lavaan package. Again, we are the Center for Customer Insights and Digital Marketing, a center here on campus under the College of Business Administration. Okay, so table of contents there. So greeting and introduction. So my name is Jared Griffin. I am a master's student in digital marketing. I'll be your moderator. And I'm also the marketing analytics specialist here at the center. Dr. Jung, did you want to introduce yourself?
Yes. Hello, everyone. Thanks for joining me. I am Jae-min Jung, and Professor of Marketing, Director of the Center, as well as Director of the MS in Digital Marketing program. Right. That's it. Let's move to the next slide.
All right. So yeah, this workshop will be recorded and then will be edited and then later posted to our YouTube. If you just want like the raw version, you can kind of reach out and contact any of us and we'd be able to send you out a kind of unedited, unformatted, raw video. The slide materials are available at this URL, but you likely want to see these live slides and follow along. Well, actually, there's not too many slides, but I will send that out anyway. And then if you have any questions, if you want to go ahead, type them in the chat, or we can kind of wait when we get a little closer to the end, just to kind of not interrupt any flow. So the overall agenda is going to be our greeting and introduction. That's now. That announcement I just made. We'll talk about our expected learning outcomes. And then Dr. Jung will go ahead and discuss SEM. And then we'll have a Q&A at the end. So what are these expected learning outcomes? Well, after taking this workshop, we expect you to be able to apply the lavaan package in R to specify and estimate structural equation models, perform confirmatory factor analysis to evaluate latent constructs, assess the measurement model for model fit, construct reliability and validity, construct reliability and validity testing, address and mitigate common method bias in measurement models, and that will be it. Okay, I will go ahead and specify, estimate, and evaluate structural models, as well as interpreting key results. And then we will open up for Q&A at the end. All right, I'm going to go ahead and stop sharing so that Dr. Jung may take it away from here.
Thank you, Gerald. All right, let me share my screen. So in this workshop, I'll use R to demonstrate how to do CFA, confirmatory factor analysis, and and then the structural model. And I assume that you know something about R. If you are completely new to R, it may be overwhelming. I will use my own research to demonstrate, and I will also not going to kind of explain very basics of measurement model and structural equation modeling. But when it's necessary, I'll try my best to explain. And so All right. Now, if you had attended our previous workshop this semester, we used Quarto to do everything, and I'm going to use the Quarto as well. So what you see on my left screen is a RStudio IDE, and then on my right side, it is a report generated from Quarto. And when I click the render button, this will be generated. So I put this together and go between RStudio and this HTML report to illustrate the process. So let me also here briefly explain the project. As you can see, is about, let's see, the COVID data, the survey that we conducted December 2023. Okay, and so we had it is a survey data collected from the one of the consumer panel, and we spent a good amount of money to collect data, and then we went through a process. So let me show you my screen, under the files here. So these are the files that's in the directory, the project directory. And then as it gets complicated, I numbered QMD files, and consequently the HTML corresponding HTML files in number. So this is 1 through 1, 2, 3, 4, 5. So the first one was this. I ran the exploratory data analysis and cleaned the data. So here, let me briefly open this up in the browser. Okay, and so it shows the process. Let me process of data preparation, and so you went through data preparation, reading data from SPSS and the Prolific, which is the platform, consumer the panel platform from which we collected the data, and then we join them and then make sure the data is good, and we cleaned by various criteria we set a priori, and then went through the sections of each of the survey sections, and went through them, and actually without questionable the responses, and then we at the end, then we emerged with, and these are the criteria that we used. So if they didn't consent, but they didn't commit, they were excluded from analysis. And we had also the 4 checks, two attention checks, and 2 comprehension checks. And then, so we ended up having initially like 800 people. And then we went through further cleaning process in here. Let me quickly open. And and then we kind of ended up further refining data from 800 to 736, right? And then at the end, it was saved. And then step 3 was looking at the descriptive statistics and just understanding the data overall. After that, finally, step 4, confirmatory factor analysis. Okay. So so the data has been cleaned, and I'm going to focus on this clean the data. And these are the packages that we are going to use. Tidyverse, Heaven, and the janitors, psych, and then lavaan is the main one for structural equation modeling, lavaan and SAMplot and SAMtool. So those are 3 are going to be the workhorse for SAM. So here, we are going to read the data, okay? And unfortunately, this data I cannot share with you. The data is, I'm still under data analysis and it's not complete. So perhaps in the future, when the review is done, then perhaps at that point I may share, but right now. So here, this is the data set that include a total of 736 people, right? So read using read say SAB file. So yeah, and then we are going to call that here. I'm going to execute one line at a time. And all right. All right. And I like to use this VUDF, which comes from this package, SJplot. Okay, this nicely presents you with data dictionary so that you don't have to refer to your survey. Okay, so it shows all the data, and then here the label associated with the variable, and the values and is value labels. Okay. All right. And then here I have a few code that just to check the integrity of recode. So I check this called behavioral intention. And then since it's long, I wanted to make the variable name short, and that's to make this coding look nicer. So here I counted, and there is a good match between the original one and the new one. And there's no discrepancy, so that's good. And also look at some other new variables that are created. Um, and then one thing that I learned is that you don't want to have a missing value for circular reduced modeling. So uh, so you okay. So here once again, I recoded and I checked the integrity of recoding by comparing. This is a original one, this is a new one, and counting them side by side, we can match. There's no discrepancy. So reverse coding is completely, it was done. So now we have a large data set. You can see if you, there is lots of variable, 270 variable. Okay? That's the number of columns, and this is number of rows. So here, I want to make it simpler because I do not want to scroll up and down too much here. So here we are going to select um, okay, select the here right here. We'll select the ones that we need in the model. So I have here individualism, collectivism, and I have a cultural values, power distance, masculinity, and uncertainty avoidance, long-term versus short-term orientation, indulgence, and then um, and and then these are the uh, civic consciousness, and then these are the variables associated with theory of planned behavior, perceived behavioral control, and these are subjective norms, the three items, an attitude toward behavior, and then this is a behavioral intention and underlying health conditions, then ages. Okay. And so I'm going to save data, and then here I'll take a quick look at the data to see uh, uh, to have a quick overview of the data. And I'm focusing on the number of missing values here. There is one missing, and then here's another one, right? So we need to, since there are only a small number of missing needs, I'm going to just drop them. Okay. So here I use drop NA. Okay. And then subject to scheme function again. And now they're all dropped. Okay. So all right. And then we are going to save the data after the drop, and this is a model only and no NAs. Okay, so I save the data, and then now I'm going to here scheme. I don't think scheme I don't need it this again, so I'll delete. And then here, let's take a look at those selected variable only. And also, you can print out this new variable. And now we have a 731 by 69. So 69 variables and 731 participants. Okay, so because we lost 5 missing values for the entire response for those people were dropped. All right. So here I made a small note here. And by the way, at this point, I'm going to render so that I can convert this code into HTML. So Quarto's main role is converting our code into HTML file. And then we can have that HTML file conveniently inside RStudio, and that's oftentimes convenient. All right. So as it's doing the work, we can continue. All right. So here I made a note that we are going to use this data set with a sample size of 731, right? And also, I would like to save the data. Okay. So now you can see the nice report was produced. So this is where, so right here we are about here. So before before we go further, I would like to save this data that I prepared for SEM. So what I want to do in this report, I mean, in this QMD file, I'll do only CFA model, and I want to have another one for SAM. And when SAM, I do not want to repeat this data preparation step again. I want to directly read this data. So here we use write save function from Haven package. And then this is the data set. And we are saving as a .sav file, SPSS data. And that location is under here, data. So I'm going to, I have this data folder. And so when you run this, we should be able to find it when you click the data folder. Okay. All right. now going back to viewer tab, you can see the rendered HTML file. Now, once you create this HTML report, now all you need to do is just when you prepare your manuscript, you can just use these. You can just use this, and then maybe you can use your favorite word processor like MS Word, and you can interpret, and you can yeah, you can write the result as you refer to this. So this was our original model that led to the data collection, the survey development and data collection. And I wanted to have this. So what I did was I screenshot that model that I have in MS Word, and then save that as a PNG file and make that available in my local, in my drive here. And then I am reading that by, here's the code. Okay. And then here, the Quarto also allows you to easily navigate. So I created this hashtag fit model. That's the ID for this figure. So whenever I need to cross-reference it, I can cross-reference and come back here. Later, you'll see how I did. All right. And then here, first thing I want to do, let me go back. So here's the models, looking at the impact of the cultures on the attitude toward wearing a mask, right? And then we've hypothesized that civic consciousness will positively influence attitude toward wearing a mask, right? And then which in turn influence positively intention to wear a mask when someone's staying in a coffee shop more than 15 minutes. Okay. And all right. Now, all right. So where, let me show you a little bit here. Okay. So now I want to create an empty space, because we'll create a number of models. And right now, I'll create a empty list of no element now, and then fits as a list, and V, meaning for a vector. So, and then same fits here. And I wanted to investigate CFA separately first, separately exogenous models first, and then endogenous model, and then later combine them all in one model. And okay, so that's what we'll do. All right. So at this point, you are going to need lavaan packages. So here, you load up lavaan library. And then, and this is how you can set up the model. So here we have 4 constructs: individualism, collectivism, the civic consciousness, perceived behavioral control. Okay, and okay. All right. Now those not knowing what each of these means is kind of hard to work with. I would love to share what each of these question items look like. Let me see. But I think if it's necessary, really necessary later, I will do that. But at this point, I'll just keep going to save time. Okay. Just note that these are the observed variable, because these are each of those 6 items are questions that make up this invisible latent construct called IND, meaningful individualism. Okay. And then here collectivism is also 6 items. All, and then here's a civic consciousness, 6 items. So to do that, you have equal and then tilde, equal and the kind of waved one. This look like this. Okay. And then you need to surround those model with single quotation or double quotation. I'll use it interchangeably. Okay, and then I want to put the model, call the model M0, model 0, and put that inside the list we created earlier. All right. Now you have to highlight, otherwise it doesn't work. In the tidyverse way of coding, normally you don't need to highlight because they're all chained together. Each line of code are chained, and you can put your cursor anywhere inside the code, and then you'll be able to run it, but it doesn't work that way. So highlight like this, and then execute, right? And and then now you see inside in the models list, it gained 1 element. So list of 1 now. All right. And then to run the CFA model, confirmatory factor analysis, okay, there's a concept called CFA and then EFA, exploratory factor analysis. And the EFA, the CFA is the right way because we have a specific we set the model like this. See, we are saying here each of these items are only manifested indicator for individualism. They are not specified to be the indicator for the other latent variable. Okay. The EFA will not specify this relationship. It's going to try to see which items will be also look at all kinds of relationship, all combinations of relationship possible. But in CFA, we look at we set the relationship according to what we believe theoretically, right? So here's the CFA model. So I mean function. So here's a CFA function, and then inside that function, it's very simple. You give the model first, okay? And then data. So data is, this is the data, right? That's the final one with 731 observations. And then here, standardized latent variable. Give me standardized latent variable. And then I will save this model fit inside fits list. And its name is going to be MO. The same as I matched it exactly the same model name, but they are under different list. So there's no problem. All right, to see the fit, then we use summary. Summary function is, it is one of the first the base R function that we learn when the people start to learn R. So it's the same old base R function. And there, and here's the model. And then we say, give us fit measures true and standardized true. Okay. So at this point, I want to say, if you think that this is a lot to memorize, there's no need to memorize. Since it's code-based, you would start the code. Once you have a code, then you can keep using it for different projects. Just have a different specification for your model, and then the rest of them is quite the same. All right. So now this is our first CFA model, right? So what do we want to look for? So let's look at briefly pre-noun. So here is the model. This is the model, and this is the Basel model that is tested against. So here is the chi-square value and degree of freedom. And this is p-value, which is normally huge, and that's right. And then here is the CF comparative fit index, CFI and TRI. These are, we want this to be above 0.9 and preferably close to 0.95. I've seen that a lot of people these days report as high as 0.95. So we can see there is some problem. Now also RM, the root mean square error of approximation. We want this to be 0.08, below 0.08. If it is between 0.05 and 0.08, that's kind of medium level of the error. If it's greater than that, then that's not good. If it's below 0.05, that's great. And the standardized root mean square of residuals is tend to be also high. So we know there's some problem. So here my focus is on looking at the size of factor loading. Okay. Now, if you are completely new to the idea of structural equation modeling, it is sort of a simultaneous like modeling of many regulations, traditional sense of regulation analysis. So as you can see in this model depiction, right? So let's say the civic consciousness is independent variable and is influencing, affecting attitude. So in that sense, attitude is dependent variable. At the same time, attitude serves as independent variable for the intention to wear mask, right? And then attitude is also influenced by subjective norm. So you can see there are many the relationships, and there's so many different relationships, and we are modeling all those at the same time, right? So if we just isolate here the relationship between the construct, latent variable, invisible here variable, and is observed variables, right? That is, the error goes from individual independent variable to each of observed variable separately, right? And then there's going to be an error associated with, because of that, right? Associated with each of the observed variable. So observed variable is set as a dependent variable, right? Each of them separately dependent variable, and the latent variable is independent variable, and therefore there is an error associated with each of the independent, the dependent variable, this one. Okay, so we have 6 different simple regression, and we are modeling it at the same time. And then the regression coefficient, we call that factor loading. So these are the factor loadings under estimate column. This is estimated factor loading or regression coefficient. Okay, and then we'll also see later below, here's a variance. These are standard, these are the error terms, estimated error terms. Okay. So that was that. Now, standardized all under that column, there's a standardized factor loading. So when you report in a manuscript, that's what people use, this one. So here we want to see, we're going to focus on this one and then see if they are large enough. The cutoff that I used was 0.5. So if it's less than 0.5, then that item is not related to, not a good job. That item is not doing a good job in representing the construct, invisible construct called individualism. Okay, so they're all large and they're all significant here, right? They're all p-value is all less than 0.05, the standard cutoff point for any, well, all the statistics that I know of, right? So collectivism, 6 items, they're all also large. Here's a civic consciousness. We have a problem there. Okay. Civic consciousness 4, 5, and 6 has a low loadings. So they're okay. And and then perceived behavioral control, we have a problem there too. The first item and the third item is below 0.5. Okay. So that means, we in the next model we can drop those 5 items, and okay, and then I guess that you may also want to revisit the name of the construct itself and see if that makes sense, and why, and those, okay, why those items are not a good items. Okay. So at this point you'll want to take a look at it, and so here in my folder I have here right. And here is that Partrix survey. To and I'm trying to yeah, unfortunately I don't have those items ready. So let me, all right. So the problematic ones is civic consciousness. It's a PVC, behavioral intention. Okay, I think here's the cultural values. Here's individualism, collectivism, power distance, here's masculinity, uncertainty avoidance, long-term orientation, and I think it's gonna come pretty soon. All right, here it is, civic consciousness. Okay. Okay, so civic consciousness, um, okay. Right, the first item is I often think about how larger political and social issues affect my community. Okay. Second one is I believe that I should actively participate in civic activities that benefit society as a whole. Okay. And the higher the number, the, the greater agreement on 1 to 7-point scale. Third one, I tend to engage in democratic process for the benefit of my community. We uh, added this one. I am younger than 18 years old. This one, we inserted this kind of in the middle as attention check question, sort of implicit the attention check questions. So the right answer will be like strongly disagree or disagree, at least these two. If someone say, I agree, they don't pay attention and they will be kicked out of, well, if they make a similarly fail 2 out of the 4 attention check questions, attention check or comprehension check, they were automatically kicked out of the survey. So they got this, and then the next one, let's see. I would be wrong to pursue my self-interest when doing so may harm the interest of the others in the community I live in. Okay. And then, so does this really look different than the first 3 question items? The next one is a single person section, no matter how insignificant it may seem, could affect the progress of the whole society. And 6, when I see someone suffering, I cannot pass by the person without extending my help. Yeah, it's difficult to say. And it might have, one interpretation is that placing these attention check questions somehow make them process information differently. Okay, so all 3 items after that, they somehow kind of read it, the level of attention or their thought process might have been disrupted right after that. Okay, so that's my interpretation. So unfortunately, they're all bad, and we'll have to they exclude them. PVC, the first word is even negative. In the third one, let's look at Mhm. Videos. Perceived underlying health conditions and perceived vulnerability, germ effectiveness, RST. Let's see. Initial subjective norm, attitude, and here is perceived behavioral control. The first item is 1 to 7-point scale. And yeah, there was a recoding, yes, a coding issue. So I had to recode it. Wearing a mask when I stay in a coffee shop will be entirely up to me. Okay. And then I will be confident that I will wear a mask when I stay in a coffee shop if I want to. Okay, that's the second item. So it's like entire up to me, and so that seems a little bit, in the hindsight, different than the second one. How about this is the third one? I would have no control to wear a mask during my stay in a coffee shop. That is third one. Fourth one, I'll be able to wear a mask during my stay in a coffee shop. So it appears that, okay, this is final one. I can easily wear a mask during my stay in a coffee shop. So the first and third tend to be the one's ability, uh, you know, uh, putting one completely in charge of determining one's act of wearing a mask. So one is completely responsible for that, and maybe that is the reason. So kind of it makes sense. The data seems to make sense. All right. So now then our next, I nicely organized that result. And then because I wanted to make a note, so I copied this result and put this text area within Quarto. And then I made a note that these are the problematic. And then here I said that these are the 5 items. So our next step is going to drop the low factor, drop the 5 items. So let's see, in model 1, we repeat the process. And and then so here I deleted those 4, 5, 6, and then 1 and 2 for a PDC. And then here run the model. And then you want to you can almost copy the entire code chunk and then simply replace model 0 to model 1. Okay. And then we call it model 1. And then here's a summary. You could also use SemPlot library to plot with the same function. You can plot this relationship like this. But normally with the lavaan, this is not very readable. So I don't, unfortunately, I cannot find a better printing outcome than this. And then you can also look at the modification and see, let's take a look at the first. Here is a, okay, here is the output, but I already have that output here. So let's just look at this. Here you can see the CFI and TRI improved a lot. Okay. And let's see if the latent variable is all large enough. The factor loadings are now all above 0.5. Okay. And this is a modification indices. Okay. And they all sorted by the size of modification indices in descending order. And so this one is quite large. So it's indicate that if we relate the error terms associated with the collectivism 1 and 3, then we can improve our model fit. But you don't want to just fish, just use these criteria to improve model fit. You'd have to be able to justify theoretically why that's necessary, and I can't do that. So I'm not going to follow this recommendation, right? So at this point, I want to create a function so that I can keep using it to compare core fit indices. And I went through this, this laborious process, and and so here is, for instance, this is the fit indices, and you consider a lot of fit indices, 47 of them. But we don't need all 47. So, okay, and it is a list. And I look at the class. So this produce all those 46, the names of those fit indices. Okay. And so what I want to do, you can pick the ones that you need. And so here it is. So I want only these, and I want to call it fit indices and put that in the V list. Okay, so that I can use it later. And I create a custom function to get those. So here, I will, in the interest of time, I will I move on fast. So you can see here, I just copied this one into here, right? And then the output is going to be called X. And then I will get the rounded value of that X indices. And these are the three inputs that you can I can use in the future. So fit indices and digit. So default is a 3-digit. I want 3 digits. And then the fit indices default will be those fit indices that these are the ones that I want. So key fit indices. Okay, and normally I just would need to feed the model like this. Okay, so when I create core fit indices, now I can get those by passing, and now I got 13 of them, but still doesn't look nice. So here I can, we can use the S apply from base R, and then this is that this is a fit list, and currently we have two of them, and this is the custom function. So when we do, it will create this side by side nicely, so we can compare two models. So there, for instance, CFA model like this, and it shows the chi-square and degree of freedom, the ratios, and it reduced considerably, so that's nice. All right, so we can have all future models side by side like this for comparison. And then I can even keep, create, run this. We make this row name to columns, like nice table, and then rename. The row name is not diagnostic, so we'll call it fit indices. And then after that, subject to GT table, and then title it model fit indices. Then you get this nice table show up. All right. And all right. I tried the different ways as well, so I just skip that. So you can also, although I didn't have any theoretical reason, I just wanted to illustrate how you can improve model fit by following the suggestions from model fit indices. Okay, the fit indices. So earlier, it said that by the collectivism 1 and 3 are the correlated. Their residuals are quite correlated. So by setting the correlation like this, okay, so correlated residuals, and to do that, you need a two like wave. Yeah, tilde. I call this tilde 2 times like this. This means they are correlated. So I put that in the same model set. I mean, I'm going to call it M1 underscore 1. Okay. Basically the same one with this tweak. And then this process repeated. Okay, so I change that one here, and then here change it here. The rest of them, CFA model is the same. And then of course you gotta use it. Don't forget to change, right? And then here, run it. Right? And then we can see the core fit measures by passing this fit and then accepting the other two inputs as default, and then transpose it so that we can see it in more column wise, and it's easier to see. And again, if you want to compare the entire three models, so far we have three models and three fits, right? So put that fits list here, okay? And then the function for fit measures, okay? Then now we get three of them nicely, and you can compare M1 and M1 underscore 1, right? That was the CFA and TRI are around 0.5, 0.95, right? So certainly it improved. RMC is also reduced and close to 0.05. But again, we just can't, we shouldn't just do it because it improved the fit. Likewise, I did a CFA modeling for endogenous model. So these are the endogenous model that, endogenous model is, endogenous variables are the ones that receive like an action, right? These are sort of dependent variables, subjective norm, okay. And then here, attitude toward the behavior and behavioral intention. Although attitude toward the behavior serves as a independent variable for behavioral intention, is still considered endogenous because it is then affected by a set of cultural values. And then the underlying health condition, this one is a moderator. So I put this one here as well. And then we call that model 2, M2. So that's the only changes. And okay, so I'm going to run the entire one. And then all right. And here is the result. I put the result here. As you can see, let's briefly look at CFA and TRI. They are pretty high, above 0.95. So it looks good. And also the model fit comparison, it's relatively high. The model fit indices, modification indices. We have a few high ones, but they are, again, you don't want to rely on that. So this time I put everything together here. Okay. So, okay, by checking my time, it's 12:45, but I'll go through since we covered the basics, I'm gonna go a little faster. And after we identify the best confirmatory factor analysis model, the measurement model, then we'll test it, the reliability, discriminant validity, and the common method bias. So I'll go fast. Okay. All right. Maybe I will use. Use this one, go faster. Okay, I put all of them together here. And I even put those ones that are identified as bad items. And as you can imagine, the factor loading is still bad. Okay, so I put them. So the next time I remove those 5 items, and then it looked pretty good. Okay. So I moved reliability and validity. So here with model 3_1, here you need the SAM tools library, and then this is how you can get Chromebox alpha reliabilities. They are all high, greater than 0.7. And then here, I just wanted to check. This is a way to create alpha using psych packages, and the raw alpha is here, and there's a way to check other things, and that matches with the one here. So I feel good about that the function that I get to use here. And composite reliability is the same composite reliability like this. It's the same one as before, but you don't have the tau equivalent true and observed variance variable true. If you don't put there, then you'll get composite reliability. Okay, and that's also quite high. And average variance extracted, get this. So here I have average variance extracted. We want for the convergent validity, right? We expect it to be greater than 0.5. And also all factor loadings are significant, which we already confirmed. So if we have a little problem, it's close to 0.5. But according to the literature, if reliability, the composite reliability is greater than 0.6, it's okay. So we confirm the convergent validity. Now to check discriminant validity, you want to here get the square root of average variance extracted and compare that with correlation between latent constructs. And so using these, you calculate the correlation between the latent construct in a nice table like this. So then we compare, we have a problem here. The BI and ATB is pretty high. Attitude toward behavior and behavior intention, we know that tend to be highly correlated, but it's pretty high here, right? And so using Fornell-Larcker's criteria, we compare that, okay? Compare here attitude square root of a average variance extracted for attitude toward behavior, that's 0.78, which we expect, we hope to be greater than the correlation between those. So we fail on the discriminant validity between individualism and non-individualism, the behavioral intention and attitude toward behavior. So here we need to think about, okay, what to do. Now there is a definite another approach to check the discriminant validity. Recently, 5 years ago, and that's recent in the adoption of technologies. Rancho and Cho in 2020 paper, they said we can test discriminant validity. Okay. Here and here's and there is a function that was developed according to I don't recall now if they are the ones who created that or someone else created this. So discriminant validative function exists. Okay, and then now of course you need to fit that function. You need to provide a fit. To run the fit here, I had to, well, they recommend that run confirmatory factor analysis again with standardized latent variable true specification. Okay. And then I saved it as a fit 3_1-1_1. So I feed into there. Okay. And then the result, the result is that it gives you a bunch of all the possible. I just copied only the ones that I need to look at, but it gives you a lot of a lot of tests together between all the possible combinations of the correlation between the latent variables. So here we are looking at the correlation between attitude toward behavior and behavioral intention, and here's the estimated correlation, which should be identical from this correlation. It's 0.889. And then here's a lower confidence interval, upper confidence interval. And then it also conduct a chi-square test of the original model and a new constrained model where the correlation between these two are set to be 1. Okay. And we hope that our model is different from the constrained model. So we want a large chi-square statistic with a small p-value so that we can say these two constructs are different. Okay. Now, unfortunately, the p-value is just 0.223. And the chi-square difference statistic is less than 3.84. And that's a cutoff point, right? So we failed to, we failed to reject the null hypothesis that the two models are the same, and we concluded whether there is a problem, it's not discrete, the two are not different, right? So then the question is, okay, what to do next, right? So maybe, these two are so small, similar, so maybe we can use only one of them, or we can combine both and treat them as the same concept because they are not, discriminable, right? they're the same. So here, or another option is further refine that. Okay, so I look at the model more closely. So, and then I called it model 3-2, and I proceed with revising. So when I um, look at the model, I noticed that the factor loading for attitude, the last item, was considerably lower than the rest of them. Okay, and and so here I tried. Okay, in the interest of time, I'm not going to visit questionnaire and then see uh, what it looked like. Okay. All right. So I decided to drop the fifth item. Okay. And then here is the model 3_2, and then run it. Right. Now everything is just, and then here is the comparison with that model. It's slightly improved. CFI, TRI slightly improved, right? And RMC is reduced, which is good, right? And here's some modification indices. So here I retried reliability, convergent and discriminant validity with this new model, 3_2. And and then here's the same, repeating the same process with a different model, Chromebox alpha, the composite reliabilities, average variance extracted. The average, I noticed that average variance extracted of course, for the rest of them remain the same because no changes occurred for the item. But this one improved a lot. As a result, when we taking a square root of that, it is now 0.916. And then that is higher than the correlation between the two. So which means that now, with that change, we pass the criteria set by Fornell-Larcker, so that showing that the evidence of discriminant validity. Okay. So with that, now I'm going to continue with this. So now 3_2 became the best model. Now common method bias. Common method exists, and that has become a important issues in a structural equation modeling. And if you don't report these days, they'll ask you to do it, right? So we need to show that the level of common method variance is not that serious. And it is, I don't think it's kind of possible to completely remove or there is a various ways to avoid as much as possible. Indeed, when we designed, we follow the procedure or recommendations in the literature, and we put the items, we varied the scale point, sometimes 1.5, 1 to 5, 1 to 7 point. And then we also put them in a different, ask them in a different ways to reduce common method the bias. Now, despite all those precautions, you will usually have to deal with that in a data, because when people read it, they all they tend to read fast, and they don't, and therefore, they are not likely to pay full attention, and it's almost difficult. So first we need to assess the degree to which we have the common method bias. And there are two different ways I did. The Harman's one-factor model, that's kind of that is a very basic one. But you can also do using this single common method factor approach in a confirmatory model. So here is our original model. Okay, the best model that we have so far. So, and then you model this common method factor. Okay, so the way that you are doing it, if those we are creating this latent construct called common method factor. Okay, here's a theoretically, and then use the rest of the items and as an indicator, right? And then we put here multiply by A for each, like this. Okay, so they are all loading up, and kind of the loading, because the factor loading is going to be here the same. Okay, because they are taking the same care for each, when they read each question items. They are, we don't believe they will somehow systematically change the way that they read and process information, and therefore kind of the factor loading should be the same. And then here we are setting the relationship between this common method factor and the latent constructs. They are completely uncorrelated. So here we multiply that by 0. Okay. So this is the whole model, and then we save it as a model number 4, and then just pass it through identical CFA model, except that the model name is different. Okay, and with that, here what we are interested in is we want to see how much it improved. This is that one compared to M3_2. You can see it improved. CFI, TRI improved, and then RMC is reduced further. This is reduced further, right? This is reduced further. All right. So then you can formally test how significant the fit improvement was by using ANOVA. Okay, so here's the 2 fits, and then p-value is here. Here is the chi-square difference huge, above 3.84 cutoff point, and p-value is very, very small. So we can say this incorporating common method improved the model fit a lot, which means that yes, there are common method bias. Okay. Now, so as you can see here, visually, we have another common method factor in addition to all these latent constructs. And then all of these items are all set to be the reflection of the common method vector. So, all right. And, all right. The second method is Harman's one-factor model. It is, okay. So I did that in two different ways. You can use CFA, you can use also PCA, principal component analysis. So first, CFA approach. Now, here, we are only modeling the Harman's, I just call it Harman's, the common method vector, which is not common method vector. So you can see there's no other latent construct except for Harman. So we are treating that all of them is, if there is a serious problem, if people don't really discriminate each locations according to its intended latent construct and treat them all the same way, then we'll have a one factor, and this one factor model should have a good fit. That's the idea. So we run that, okay, and then here is, okay, here is right here. Here is that I call it M3_2 Harman, and look at CFA and TLI. It deteriorated a lot, okay, and that means that this one model is not adequate. So although there was a problem, common method bias exists, but it's not that serious. Okay. We also look at formally a ANOVA test, and then these two models are significantly different. Okay. So here is the depiction of the one single factor model. And if you want to use the CFA model, which is also available in SPSS, you want to first select those items that you want to use. Okay, so notice that I don't have a ATB, the fifth item, because best model, we remove them. And then here's a new data set. Okay, and then with the new data set, we use FA, factor analysis, and then say number of factors is 1, rotation, no. And then here, look at the factor diagram. It doesn't look good, but it's not, the feature is not very nice. Here's another one. Is a principal component. And then here's the summary. And we need to focus on here, cumulative proportion with one factor, we get, we explain 33% of the variation, okay? And the norm is that if it is less than 0.5, it's okay. The common method bias issues is not that serious. And in order to three factors together, now we represent about 55% of the variance. And so there's we have how many factors we expect? 6 or 7. We have here 1, 2, 3, 4, 5, 6, 7, or 8. So I'm gonna go back. So 8 of them together is represent 78% of the variance. And here's a script plot that shows number of factors whose eigenvalues greater than 1. Using elbow method, we have 1, 2, 3, 4, 5, that's about 6 factors whose eigenvalues are greater than 1. Okay, so that's the, so we feel okay with the measurement model, and then after that, we'll proceed with structural model. So here is, so here I'm gonna just briefly show you, and then we'll conclude the workshop. So here, once again, I have the packages, and now I'm going to read this data that was saved from the previous tab, the CFA model, where we prepare the data for CFA. So that reside in my data subdirectory, and I'm going to read it. Before that, I just clean up here, clean, so that the new step, anything that I create from new step is not associated with it. For if I somehow named the lists or some variables the same way, I may end up using the data that I created from the previous tab, which may lead to an error. So I read it and I call it COVID model CFA. I check the number of rows, and 731, that's correct. Here's the data dictionary. Okay. And now, as usual, I'm gonna set up list. This time, models, I will call SAM models. Since I removed all previous output, I could just use the same name, but I'm going to make it these changes. So SAM tools, and then fit from those SAM models will be called SAM fits. Okay, and then V is just the same V. All right. Now, here I am referring to this, so let me see. All right, so we are in the same here model depiction. See, so right here, this is a cross-referencing. Nice cross by saying this. Now I can, it is right below. So in this case, not much difference. But if you are referring, cross-referencing far below this model presentation, then it's easy. You will just move on there. Okay. All right. So here I'm going to just go through these. There are only a few models here. First, I wanted to, we have these common method bias. So some scholars say if there is a common method bias, you should incorporate that into your structural model later. Okay. Now some people may argue that, well, since the common method bias is not serious, although they exist, and there is it's not necessary to incorporate them. All right, so I did both. Okay, so here the first one, model 0, is the CMB incorporated structural equation modeling. So here, this is the entire model. The model is going to be quite long. So the double quotation here, right there, and they start here. Inside the model, you can add comment. So anything that below sharp is a comment, and I use it to organize. So I said here, measurement model, and then there, here's exogenous variables and their relationship with the indicator look like this. Okay, and then here's endogenous variable, and then here's a moderator, and then here's the common method factor that I copied those that I run before. Okay. And then this is our goal, right? Structural regression models. So here we are specifying the expected relationship between the latent construct according to the hypothesis. So here, individualism, by the way, I have 6 different cultural value constructs, and in an exploratory preliminary analysis, I used them all, and model became very complex. So now I am exploring, just use most important cultural dimension, which is individualism and collectivism. So that's why I have only 2 of them here. So it's like a regression model in the sense that we regress this attitude on individualism, collectivism, and civic consciousness and subjective norm. Okay, and then we regress behavioral intention on subjective norm, attitude toward behavior, and perceived behavioral control, according to our hypothesis. Okay, and then we call that, we save it as a M0, so that's kind of a base, and probably most accurate depiction of the model. And then here's the data. So it looks quite similar, same, similar to CFA model. But instead of CFA, we use SAM. That's all there is, right? And then we save it as like this, the name of that. And we pass that to summary function. Okay, and we say fit measures, yes. Standardized solution, yes. R square, yes. So give me all those things. And here is that result. Okay. Looking at quickly, CFI and TRI is quite high, and this should be almost identical to the CFA model, its corresponding CFA model. Okay. The only thing that we specified differently in this structural model is that we added only this part. The rest of them is the same model. Okay, that's the measurement model. And then on top of measurement model, we are specifying the path model. Okay. And with the structural equation model, we don't really worry about the fit because the fit has already been varied during CFA analysis, and the measurement model looked good. Then the fit is no longer our concern. So our our concern, the most important thing is the relationship between the hypothesized relationship under regression. Okay, so this is what was most important. And the p-value is all significant, so that means they all statistically significant. Individualism is negatively influencing one's attitude toward wearing mask. Which, and collectivism is also that I expected individualism will be perhaps negatively influence attitude toward wearing mask, when collectivism is positively. But both of them is negatively here. Now, civic consciousness, the most greater civic consciousness mindset one has, they are more willing to wear a mask because it helps other people. So I expected positive relationship, but it's negative, right? So collectivism is positive, but negative. And then this impact of subjective norm on behavioral intention, they all should be positive. Okay, positive and attitude, positive attitude lead to positive intention. Greater perceived behavioral control lead to the positively intention. So these all look good, but these are not good. And right. So here, further investigate. Okay. So you can. I think there was a. Let me actually. Here process. Okay, let me. Initial model. So when I was running this, I think there was a warning. This was warnings. Same model. There was a warning messages, and it said covariance matrix is not positive definite, and use this to investigate. So I use this to investigate, which produced covariance matrix. And that if there is a negative value for the variance, there will be a diagonal line represent variance. So they should be all positive, which is true. So I don't see a problem here. Okay, so here, so I proceeded, and yep. So next, I went to, I call it initial model. This time, I'm not going to incorporate common method bias because it's not serious. So we'll have just the measurement model, which is M3_2, the best measurement model we have. Okay. And then I added just these, the path model there. Okay. And I call it M1. And then I run. I no longer see the error messages. And then here is that output. Okay. Okay. And then the output, as you, okay, here is the regression here. So now the impact of individualism on attitude toward behavior is not significant. Okay. However, the impact of collectivism on attitude toward behavior is significant, and the direction is consistent with the hypothesis. The more collectivistic one is, more positive the attitude toward wearing mask, and that makes sense. Also, the greater civic consciousness one has, the more positive toward wearing a mask. So which also makes sense. The rest of them all consistent with theoretical expectation. So I feel that this model looks better. Although the fit, if you compare the fit, again, the fit is not the concern. The fit will be much better with common method bias incorporated. And that's natural, but that should not be the reason we should use common method bias incorporated model. On top of that, I was worried about the indefinite covariance warning associated with common method bias incorporated model. Okay. So here I want to compare them side by side using the same the custom designed function, and I'm going to call that core fit measures SAM. And then, right, and then if you use that, if you have one, it look like this. But if you have a multiple one, now when we pass SAM fits, we know there are two models. So now the model is presented like this. Okay. So if you are just comparing the fit, the model 0 is better, but the model 1 is still, it still looks good, because that fit should be identical to, almost identical to the measurement model that we already decided deem adequate, right? And therefore, I feel good about it, and we are done. So we run both measurement model and then structural model, and then you can stop here. And of course, if you want to look at moderation, then you have to further do, which I have to do for this project. But today's the workshop is going to be only some basic things. So we are going to stop here.